So we'll take a look in this video on hypothesis testing and actually confidence intervals when we have two proportions given to us. So start off with a two proportion z-test. Hypotheses are going to be very, very similar, right? We have to have the equality with HO, right? It's either equals to, greater than or equal to, or less than or equal to, and then HA will always have the inequality, one of those three symbols with it. Conditions here, things are going to be a little bit different. Um, one, instead of a single random sample, we want to make sure each is random. We want to make sure each population is bigger than 10 times the sample. And now we have a new condition. This is brand new to us. It's called a pooled proportion. And all that really is you're going to take both successes and divide by the sum of both sample sizes. That's going to be p pooled. Now, one thing to note, as far as we're concerned, we'll only pool for a two proportion test only. That's all that we're concerned about right now. I know we've seen pooling as an option in the calculator before, but for us right now, in terms of what you need to remember, you only pool for a two proportion test. So the test statistic, again, it's still that observed minus predicted over the standard deviation. Now be aware, we do have the p pooled is down here. And as a quick reminder, this is because we're saying P1 is equal to P2. If I move them to one side, P1 minus P2 is going to be 0. So that's where that 0 is coming from, and it's just a placeholder. P hat 1 and P hat 2, these are just the observed proportions. So we've seen that before, but now we're going to compare two of them. All right. So let's look at an example. So if the National Sleep Foundation took this sample, and of the 995 respondents, 37% reported they snored at least a few nights, and they split into categories. They split it into those over 30 and those that are under 30, or I should say 30 and over. So what we're going to see is there a difference in the two groups. So if we take a second, kind of a chart like this would be very, very helpful. Um, do some quick math, and there's what the sample proportions would be. So first things first, name this test. This is a two proportion z-test, and we start running through conditions. Each was from random, right? Split into two groups. They did a random sample, excuse me, there it is, up at the top. Next, population 1 and population 2. So here we're going to call population 1 those that are under 30, and we'll say population 2 30 and over. Right, so far the first two conditions are met. Now to get that third condition, here's how we do the pooled, right? So the x values, right, in our calculator, those are our x values when we go to the test. We're going to add up 48 and 316. That's what's here. And then go ahead and total your sample sizes. So our p pooled value here is 0.365. Let me erase that so it's out of our way. So that's what we're going to use to check our NP and NQ values. So again, this was the P pooled. All right, so this is P pooled and Q pooled, which is just 1 minus P pooled. So that's what those two values are. Right? And so those are the first, that's N1. And again, there's N2, 811 that were 30 and over. So there's the one big difference so far. All right. So all of these things are greater than 5. Let me get this out of your way so we can read it clearly. All right. So the hypotheses. We're just testing to see was there a difference. And so that's your set of hypotheses. And what we could do, we could move them to one side. I showed you earlier where that 0 came from. There it is again right there. So the mechanics, we'll just plug and chug, right? Plug in the right values. Keep it in mind, right? These are the P pooled, right? That's P hat pooled and Q hat pooled. The reason that I'm putting a hat on those is because if you go to the calculator, you'll actually see it'll put a little P hat underneath those values. So we're at negative 3.27 for a p-value of 0.01. That's less than 0.05, so we will reject the null, which means that there appears to be a difference, right? Keep in mind, right, HO was that the two proportions were equal. Well, we rejected that in favor of HA, which was that they are not equal. All right. So we can take a look at another example. Here's one on book purchases. So 5 out of 22 men purchase books online and 37 out of 208. So is there evidence that men are more likely, right? More likely. So we'll run through quick. There's only one name for this. There's only a two proportion z-test. No such thing as t in this situation. We want to make sure that there's more than 220 men and more than 2,080 women. That's a safe bet. And there again is how you calculate p pooled by hand. Um, the total number of successes over the total of both sample sizes. Again, the calculator, when you run the test, you're going to see, if, you know, on the calculator screen, it's going to give you some values, and it'll give you p hat 1 equals something, and p hat 2 equals boom, boom, boom. And that's where these would come in. And then right under the p hat 2 is just a p hat. Well, that is the p pooled value. So the calculator helps you out with this one. All right, so quick check, but here all of a sudden when we did the n times p pooled, we have one that's not bigger than 5. Not a big deal. We just note it and we keep moving. So we'll set up our hypotheses, and you can move them all to one side if you'd like. But just plug the values in. Again, keep in mind, use your p pooled and your q pooled because we're running the test. So our z-score here is 0.57. So our p-value, right, there's the p-value, the 0.284. We're going to fail to reject, which means that there does not appear to be a difference, right? Because again, HO, now all of a sudden this is what we think is true, that P1 equals P2. All right, so when we test, what we do is we assume as we do this, excuse me, we assume that HO is true until we see something unlikely. And where we see something unlikely, right, what we're going to do is we find the likelihood of obtaining a sample assuming HO is true. And that's what a p-value is. Whereas when we set up an interval, all we're really trying to do is we're trying to estimate the true value. So that true value, it could be a mean, it could be a proportion, it could be the difference of two means. Trying to estimate how different are these two means in these two samples. Or in this case, what we're about to do, we could also be trying to see, is there a difference between two different proportions? Two proportions. So that's kind of the big difference so far. So as we set these things up with a confidence interval, because we don't start with any assumptions, we have a slightly different third condition where we're going to actually use NP hat 1 and NP hat 2. We're not pooling anymore. And the big reason that we did pool before, if you'll let me go back for just a minute, when we assume that HO is true, a lot of times that was that P1 equals P2. Well, if those two things are equal, we're essentially saying, let's just put them together. Well, since we're no longer working under that assumption, right, there's no assumptions here with the confidence intervals. We can no longer put stuff together. That's the basic idea. So there's your formula for a confidence interval. Again, Here's our p hats. This is the difference in the observed proportions. And then your z star, which we can pull off the bottom row of the table, the t table. And then again, these are p hat 1, q hat 1. So we're not pooling down here. So pooling's out. And in fact, the calculator doesn't even give us an option to. One quick example. So are more parents checking up on their teens' online activities? So here's the data. 33% of 868, which is 286, and then did the same, they posed the same question later, a couple years later, and 44% of 811. So there's a 95% two proportion z interval. So we're told that they were random. Quick run, make sure there's more than, right, we'll call this population 1. Basically, we need to make sure there was more than 8,680 teens in 2004. That's a safe assumption. And more than 8,110 teens in 2006. That's safe. And then here's where we're no longer using the p pooled. We're using the actual p hats, right? So we're using p hat 1 and p hat 2 with the different samples. So that's how this is going to differ slightly. We run through the mechanics, plug the right values in. Right, there's the z star at 95%. That's a good one to know and have memorized. And so here we are. We're 95% confident then that the true difference in proportions is between that. So, and again, it appears that 2006 proportion is greater. And why is that? I would add here because 0 is not in the interval. And really, this is the big reason why the entire interval is positive.